When taking a 20-question multiple choice test, where each question has 3 possible answers, it would be unusual to get how many or more questions correct by guessing alone. Now, to be able to answer this question, you have to know about a couple of rules which are attached here. Values that are unusual or rare. One of the rules is the range rule of thumb. The other is the rare event rule. And they, depending on which one you use, you will get the same answer either way. And for this question, it's a little simpler to use the range rule of thumb. In a previous video, I showed how to use the rare event rule. But for this, we can also use the range rule of thumb. And you can see that what you do is you calculate the minimum usual value and the maximum usual value. But then you will know where the fences are, basically, of what you would consider to be usual. And anything below or above that would be considered unusual. But in order to use these, you're going to need to be able to find the mean and the standard deviation. So we're going to try using this, but first we have to figure out how we are going to find the mean and the standard deviation. Okay, so our strategy is to use the guideline for unusual values, right, which is coming from the range rule of thumb. The range rule of thumb asks us to consider or use the fact that 95%, the vast majority of values will fall within 2 standard deviations of the mean. So if I start at the mean and subtract 2 standard deviations, that's a cutoff point. And if I start at the mean and add 2 standard deviations, that is also a cutoff point. So that is what we're doing here. So we are going to calculate the minimum usual value, which is the mean minus 2 times the standard deviation. And we'll also do the maximum usual value, which is equal to the mean plus 2 times the standard deviation. And for this question, we actually only need the maximum usual value, but we might as well just learn how to do it either way, because you could also get a question that asks you about a certain number being unusually low. And so you want to be able to look at both sides of that concept. So here it says that when taking 20 multiple choice tests, where each question has 3 possible answers, it would be unusual to get a certain number of questions by guessing alone. And I am concerned about how to find the mean and the standard deviation. Well, what jumps out at me is that this might be a binomial distribution. If it's a binomial distribution, then I know how to find the mean and the standard deviation, because if yes, the mean is equal to n times p, and the standard deviation is equal to the square root of npq, right? So we are hoping it is binomial, and it's binomial if we have a fixed n, and if we can boil things down to success and fail, and if we have a constant p, meaning the probability of success is always the same, right? So do we have a fixed n? Yes, we do. We have 20 questions, so that would be our n. Can we boil this down to success and fail? Yes, success would be correct, and fail would be incorrect. Only 2 things that could happen. What about the probability of success? Well, if we consider a success to be a correct answer, then the probability of success would be, since there are 3 possible answers and only 1 would be correct, that would be 1 out of 3. And then the probability of failure would be 2 out of 3. The other 2 answers would be incorrect out of the 3. So this does satisfy a binomial distribution, which is awesome, because now I can find my mean by multiplying 20 times the probability of success, which is 1/3. Okay, so there's my mean. And then we do our standard deviation, which is going to be S. Standard deviation is going to be the square root of N, which is 20, times P, which is 1/3, times Q, which is 2/3, and then make sure to close all your parentheses and you'll get your answer. Now, it may be more convenient to make some cells for containing your N, your P, and your Q. I like doing that. And so then I'll have 20 here. P is equal to 1/3, and Q is equal to 2/3. So now when I go to do my mean, I can just do this cell times this cell, and mess that up. Try that again. Equals this cell times this cell, N times P, and this one, square root N times P times Q. And if you're really clever, you'll realize that when you did the mean, you did N times P already. So when you go to do the standard deviation, instead of doing N times P again, you can just do, this is N times P already, and then times Q. Just shortens it a little bit. And so once you have the mean, now you're ready to calculate the minimum usual value and the maximum usual value. Now, we're going to calculate these in theory and then actual, and you'll see what I mean in a moment. So when I calculate my minimum usual value, I start at the mean and I subtract 2 times the standard deviation. And to do my maximum usual value, I start at the mean and I add 2 times the standard deviation. Okay, so now I know that the highest value that I could get by guessing alone that wouldn't be suspicious would actually be 10.88, but you're not going to get 10.88 questions right. You're either going to get 10 right or 11 right. So what is the maximum that you could get in actually get right? That would not be unusual. That would be 10. And for the minimum that would be usual would be 2. Does that make sense? 2.45 would be the minimum. Usual, yeah, I think that makes sense. Or would it be 3? This always confuses me. Let me pause and think about this. Okay, I had to remind myself. The correct way to think is to say that anything less than 2.45 questions correct would be unusual. Anything less than 2.45. So 2 would be unusual. 3 would be the last one that is not unusual. Okay, but the way this question was worded, they asked us how many or more would be unusual. So we're interested in focusing on the maximum usual value. So here, 11 or more questions correct would be unusual. Unusually high, right? Okay, so then that would make my answer 11. And the easy way to remember it for this particular question is that it's always the answer for the max usual value should be rounded up to get this answer right. Hope that helps.